Here we have AP calculus AP problem. Okay, let's go the information. Find dy over dx for y equals to sine of x positive y. That is, we have to find the derivative of y with respect to x for the given implicit function. So I am saying this is implicit function because in this function it has not been solved for y in terms of x. So if there is a function something like this, y is equal to x square positive 5x positive 3, it's called explicit function because it has been solved for y in terms of x. But in this one, it has not been solved for y. Even though we have y on the left side, the right side also we have y. So it's implicit function. Okay, now let's find derivative of this one with respect to x, because here in denominator we have dx. That means we have to do derivative with respect to x. Okay, now let me write the given function as it is, that is y equals to sine of x positive y. Okay, now I'm going to do derivative on both sides with respect to x. When I find derivative of this y with respect to x, I'm getting dy over dx. So here on the right side, we have the trigonometric function sine. Whenever I find derivative of trigonometric function sine, it will become cosine. And whatever stuff we have over here, it has to be taken as it is. So far, I have computed derivative only for the trigonometric function sine. So then it became cosine. By chain rule, I have to do further derivative for the stuff we have over here, that is x positive y. Now, when I find derivative of this x with respect to x, it will just become 1. When I find derivative of this y with respect to x, it will become dy over dx. Okay, now we have to solve for dy over dx in this equation, because my aim is to find dy over dx. Okay, now let me find dy over dx in this one. So let me write the stuff on the left side. So now on the right side, what we have to do is we have to distribute this one to 1 and dy over dx. So when I distribute this cosine of x positive y to 1, so this one has to be multiplied by 1, then I'm getting cosine of x positive y. And now we have to take this positive sign as it is. We have to distribute this one to this, then I'm getting cosine of x positive y times dy over dx. Okay, now what I have to do is I have to isolate dy over dx. But here we find dy over dx on the left side and right side as well. So to solve for dy over dx, we have to get all the terms which contain dy over dx on one side of the equation. So better we can get rid of this term on the right side. So for that, I have to subtract cosine of x positive y times dy over dx on both sides. Let me do it on the left side also. That is negative cosine of x positive y times dy over dx. So when I do so, this positive term, negative term will cancel. I'm getting dy over dx negative cosine of x positive y times dy over dx equals to, on the right side we have cosine of x positive y. Let me write it over here, cosine of x positive y. Okay, now what I'm going to do on the left side is I'm going to factor dy over dx, because both the terms over here contain dy over dx. To solve for dy over dx, I have to factor dy over dx from the expression we have on the left side. When I factor dy over dx from both the terms, so here I'm getting 1 in the first term. So because we have only dy over dx, when it is factored, we have to write 1 over here, negative, and here this dy over dx is factored, then the rest is a negative of cosine of x positive y equals to cosine of x positive y we have on the right side. Okay, now I'm going to divide both sides by 1 negative cosine of x positive y. Let me finish writing. 1 negative cosine of x positive y. So this one will cancel out. I'm getting dy over dx equals to cosine of x positive y over 1 negative cosine of x positive y. So now I got the result for dy over dx, that is equal to cosine of x positive y over 1 negative cosine of x positive y.